All right. Oh, hi everybody. Hey, little winter penguin. I would like to wish you warm wishes in this new 2024 school year. Hope you're staying warm. Yay. Okay. See ya. All right. Oh, hey everybody. So we're going to start objective 3.1 where you're going to be able to prove and apply theorems about triangles. So we're getting into a unit and lesson that's all about stuff about triangles. So today we're just going to learn some kind of basic principles about triangles. So let's start with important vocab. So if we've got triangle ABC, so that just means I've got a triangle that has a point A connecting to a point C, connecting to a point C, connecting back to point A. So it's a three-sided figure. And how we name it is just either with the word triangle or the symbol, like a triangle symbol, and then the 3 points that make up the vertices of the triangle. The side of a triangle is just the 3 segments that connect to form the triangle. So we have a side here, and we can name that side segment A, B. We have a side here from B to C, and we can name that side B, C. And then our third side is from A to C. So segment AC, or CA, you can flip all these letters around. That's the side. Call those the sides of the triangle. And then the angles of the triangle are where 2 sides connect. So when I have like A, B, C here. So like angle A, B, C, or we could just call it angle B. That's an angle in a triangle, and it's the combination of like one of the sides. So like this one is the combination of the green side connecting to the yellow side. Okay. And the other 3 triangles other 3 angles are angles BCA, or just angle C, and then angle CAB, or just angle A. Right? And the measures, right, we talked about the measures of the angles are like inside those rotations. And notice I'm going to put 3 different congruency marks because the angle sizes are all the same. Are all different. Okay, opposite's going to come up in this lesson. We've talked about opposite being positive versus negative. Opposite also refers to position, and it means across from. That's the way we're going to use opposite today. Inequalities are going to come up today. That's when quantities are unequal. We use these symbols to say that. And then range. Talking about a range of something, we're kind of talking about like the distance between kind of 2 things. Okay? So in class, we talked about basketball and pass chains and how pass chains form triangles. We're going to skip over this for the video and go straight to the key points box. Basically, in the figured out section, we discovered something called the triangle inequality theorem, which says in a triangle, the sum of the length of any 2 sides must be greater than, but not equal to the length of the third side. So if we want to be sure that like 3 lengths are going to come together to form a triangle, then this has to be true. Okay, so if I have a triangle here where K, S, and T stand for the lengths of the sides, whatever K is plus S has to be greater than however long T is. However long T is plus K, that sum needs to be greater than however long S is. And then here, same idea, we just flipped around the statement. T plus S would need to be greater than K, so K would have to be less than T plus S. Okay, so we're going to look at this example where we're considering a triangle that already has side lengths of 14 and 8. Okay, so we've got this triangle here. One side's 14, one side's 8. We're wondering, can the length of the third side be any of these numbers? So to figure that out, we're going to follow the triangle inequality theorem, where we're going to take the sum of any two sides. So I'll do 14 plus 8. Is that greater than 6? Yes. But it's got to be the sum of any two sides. So I'm going to pick now 14 plus 6. Is that greater than 8? Yes, it is. Okay. Now what about 8 plus 6? Is that greater than 14? No, that's equal to 14. So this is not a triangle because of this statement. 8 plus 6 would have to be greater than that third side length, not equal. Let's try 5.5. So, same idea. Is 14 plus 8 greater than 5.5? Yes, it is. Is 8 plus, is 14 plus 5.5 greater than 8? Yes, it is. Is 14 plus 5.5 greater than, I'm sorry, I'm saying the same one again. Is 8 plus 5.5? Is 8 plus 5.5 greater than 14? No, that's not true. It's less than. So this is a no as well because of this fact that 8 plus 5.5 is less than 14. Let's try 22, and you'll get fast at these, so you don't necessarily have to write out all three statements. So I'm going to see, just in my head, do I, when I add two sides, do I get a value less than or equal to the third side? So when I look here, if I do 14 plus 8, I already see that that's equal to 22. So that's going to be a no. 14 plus 8 would have to be greater than that third side length. What about 22.1? 14 plus 8 is less than 22.01. So that's also a no. Okay, so all of these are no's. Okay. Okay, let's move on to example 2. What are the possible lengths for AB if AC equals 20 and BC equals 13? So, okay, still talking about, let's talk about a triangle ABC where two lengths are 20, one length is 20, A to C, and then B to C is 13. So it's asking, what are the possible lengths? Well, there's going to be more than one length. So there's more than one value that will satisfy the triangle inequality theorem. Like, I'm going to pick up if I make up a value, let's make up a value that doesn't work. Like 1 wouldn't work because 1 plus 13 is less than 20. It would need to be greater than 20. So the way I can figure this out is I know the sum of any two sides must be greater than 13, right? So the sum of any two sides must be greater than the third side. So if I take that unknown side x, I know that x plus 13 has to be greater than 20, right? So that means, and if I solve this, that means a value greater than 7 will work. Okay? I also know that x plus 20 has to be greater than 13. So that means that okay, I'm going to do this, sorry. I also know that 20 plus 13 has to be greater than whatever x is, right? So 20 plus 13 is 33. So then x also has to be less than 33. So the values that will work is that x has to be can be greater than 7 and also less than 33. Okay? that third statement didn't make sense to really set up because I would get a negative value for x. So I could have done when I was doing earlier and I stopped and erased. I was like, okay, x, whatever x is, plus 20 has to be greater than 13. Well, yeah, of course, x has to be greater than negative 7, right? So like you don't need to set up that third one necessarily, okay? Okay, so that's how you could use like an equation to find like what are the possible values. All right, so that's triangle inequality theorem. And then in class we did more about basketball. And what we discovered in basketball was kind of this idea. What we're going to get into now is like the relationship between angles and sides in triangles. And so I want to show you something. So let's say I have two sides. I'm going to form a triangle using this red and blue side, okay? And I'm going to open this up to form a triangle, okay? I want you to notice as I open up the angle using the protractor, the angle gets bigger, right? So right now the angle, like right now it's just like a flat line, right? And then I create an angle that's now 20 degrees, right? And then I want you to notice how this angle impacts this third side. So I'm going to make this happen. I'm going to make it so that it connects to the green side's length, okay? So about a 30-degree angle would mean that this side length is that long, is the length of the green little stick, okay? So notice, and then I want you to notice this. What if I make the angle way smaller? Notice what happens to this side length. I can make it way small. If I want to make this side smaller, if I make that angle smaller, now this side is smaller, right? So what I want you to notice here is that the size of this angle impacts how large the side across from it is. If I make the angle bigger, the side gets bigger. If I make the angle smaller, the side across gets smaller, okay? So that's called just like angle-side relationship theorem in triangles, where in a triangle, the largest side is opposite the largest angle, and vice versa. And the shortest side is opposite the smallest angle, and vice versa. So that's useful if we're looking at diagrams that are not drawn to scale. So for example, in example 3, the triangle below is not drawn to scale. ML is the longest side. So this is the longest side. Which side is shortest? Okay? Now, how can I figure that out? Now, I can use the angle measures to figure that out. Without having any like side length knowledge, I can still use the angle measures. Because I know that, okay, let's look at the angles in the triangle. So this is the biggest angle, right? So the side across from it is actually going to be the biggest side. I know they all look the same, but if you like imagine again with the sticks, this angle is actually, if I were to draw it to scale and be like a 90-degree angle, it's forming a bigger side length, a longer side length than this angle, which is going to be smaller. It's forming a smaller side length. Okay, so like I'm going to list my sides actually in order. So largest is going to be ML. Next largest is going to be across from my next largest angle, so the 60-degree angle. So my middle side is going to be DL, which means my smallest side is across from my smallest angle. Smallest is going to be DM. And that's it. Okay. Yeah, just kind of two important theorems about triangles. If that made sense.